So hi everyone, this is Jay, your instructor for computer networks, and the topic that we are going to see is subnetting for class C. So let's start. If you remember the IPv4 address, the length of the address was 32-bit. So 2 raised to 32 means 4 billion IPv4 addresses are there. So to distribute these addresses efficiently, those addresses are divided into classes, which are class A, class P, class C, class D, and class E. Class A, B, and C are known as unicast IP address, means those IP addresses are for one device only. Class D is multicast, means one IP address may be for more than one devices, and class E is for reserve, means for development purpose. Now if you see the class A address, you can see two parts, which is network ID and the host ID. Now what is this meaning of the network ID and the host ID? The network ID represents that how many networks are possible. For example, you can see that in the class A, 1 byte is for network ID, means 8 bits is for network ID. So 2 raised to 8 means 256 individual networks are possible in the class A. And from the host ID, you will know that how many devices are possible in one network. So in class A, you know that 256 means 2 raised to 8 individual networks are possible. And in one network, 2 raised to 24 devices possible, means 2 raised to 24 hosts are possible. If we talk about the class B, then you can see that in the class B, the first 2 bytes means 16-bit is for network ID and the 16-bit is for host ID. So from the network ID, you will know that how many individual networks are possible. So in the class B, 2 raised to 16 individual networks possible. And in one network, 2 raised to 16 hosts are possible. Means in one network, you can allocate 2 raised to 16 devices. And in class C, you can see that first 24 bits are for network. It means that 2 raised to 24 individual networks possible. And in one network, how many devices, how many hosts are possible? In one network, 2 raised to 8 hosts are possible. So let's see the first example of the class C network. We have just discussed that in the class C, there are total 2 raised to 24 individual networks possible. So from that 2 raised to 24 networks, one network is allocated to you, which you can see on the screen, which is 193.168.10.0. It is also represented in the binary. So we know that in the class C, the first 24 bits are for network and the 8 bits are for host. So the value of the network bits will be remain constant throughout the network. So in this network, the value 193.168.10 will remain fixed throughout the network, and the value of the host will keep change as the host changes. So first thing I need to find in this network is that how many hosts are possible in this given one network. We know that the host bits are 8. So from the host bits, you will know that how many hosts are possible in this given network. So 2 raised to 8 hosts means 256 hosts are possible. Now I want to find the first IP address of this network. To find the first IP address, we will set all the host bits to 0. So let's set all the host bit to 0. You will get 193.168.10.0. So it is the first IP address of the given network. Now I want to find the last IP address of the same network. So to find the last IP address, we will set all the host bits to 1. So let's set all the host bit to 1 and you will get 193.168.10.255. So this is the range of the IP address of the given network. Now generally, first and the last IP address will not be allocated to any device because the first IP address of the network represents the whole network. So what is the first IP address? It is 193.168.10.0. So this IP address represents the whole network. And the last IP address is for the broadcast address. Now what is the meaning of broadcast address? Any message sent to the address 193.168.10.255, all the devices in the network will receive the message. It means that any message which is sent to last address of the network, all the devices in the network will receive the message. It means that it is the broadcast address. So you can see that it is the broadcast address. Now let's assign the IP addresses to devices in the network. We know first and last IP addresses are not allocated. So we will assign IP addresses apart from them. So the IP address of the first device in this network will be 193.168.10.1. Then the next device will get 193.168.10.2. Then 10.3, 10.4, 10.5, 10.6, and it will be keep going up to 10.255. So the first usable address of this given network is 193.168.10.1 and the last usable address is 193.168.10.254. Now let's increment 1 to the last usable address. So if we increment 1 to the last usable address, which is 193.168.10.254, you will get 193.168.10.255. So that is the last address of the network, which is broadcast address. Let's further increment 1 to the broadcast address. So if we increment 1 to the address 193.168.10.255, you will get 193.168.11.0. Do you notice that value of the network is changed? It means that that IP address is of the another network. Okay, so two things should be remembered by you is that the value of the network should be remain same throughout the network, the value of the network bits, but value of the host bit can be changed as the host changes. Now I want to find the subnet mask. To find the subnet mask, all you need to do is to set all the network bits to 1 and set all the host bits to 0. So when you set all the network bits to 1 and host bits to 0, you will get 255.255.255.0. But what is subnet mask and why it is needed? So let's see. So the subnet mask 255.255.255.0, it is subnet mask of class C. We have just found that. Suppose router has received IP address of class C, that is 194.20.3.9. Let's represent that IP address in the binary. So you will get something like this. So router use the subnet mask to find the network address. So how it finds the network address using the subnet mask? So you can see that this is the received address by router and the subnet mask, both IP addresses are written in the binary. So router will simply perform the logical AND operation between these two numbers. So after performing the logical AND operation, the router will get the binary number which you can see, and for our convenience, let's convert that number into decimal and you will get 194.20.3.0. So the received IP address was of any device in the network. But From that IP address and the subnet mask, router has found the address of the network. That you can see that the address of the network is 194.20.3.0. It is the first address of the network. And you know that the first address represents the whole network. So using the subnet mask, router finds the IP address of the network. So till now, we know that in one class C network, there will be 2 raised to 8 IP addresses. So that is equal to 256. We know that 256 addresses are not allocated. First and last are skipped. So 254 devices can be connected in one class C network. You agree, right? Now suppose I want to create a network which is having, for example, 126 devices in one network. Now it is a problem. Why? Because when you purchase one class C network, in one network you will get total 254 usable IP addresses. But because you are creating networks smaller than that, the remaining addresses will be wasted. And if we do not allocate those addresses to any device, those addresses will be completely wasted. So that is why when we need to create a network which is having small addresses, then the given one, then the specified one, in that case, we will divide the network into the smaller parts. And that process is known as subnetting. And subnetting is also known as classless addressing. So let's see how the subnetting works. Now this is the same IP address that we just saw. It is the one class C network which is 193.168.10.0. And we know that the by default 24 bits are for network and 8 bits are for host. We also know that the value of the network bit will remain same throughout the network, and the value of the host bit will keep changing as the host changes. But now I want to divide this class C network into subnet. So to divide the network into subnet, we will convert the host bit into network bits. Because network bits cannot be changed, we can only change the host bits. So let's change the host bit. Now you can see that that particular bit is converted into network bit. So host bit is changed from 8 to 7 and the network bit is changed for 24 to 25. So we have converted one host bit into network bit. Now from the converted bits, what information you get? From the converted bits, you will get that how many subnets are possible in that one network. So number of converted bits in this example is 1. So from that you will get that 2 raised to 1 subnets are possible in the one network. It means 2 subnets are possible. So the first subnet is subnet 0. Now how many hosts will be there in the subnet 0? So number of host bit will tell you the number of hosts in the subnet. So 2 raised to 7 hosts will be there in one subnet. Now I want to find the first IP address in the subnet 0. So for that I'll set all the host bit to 0. So let's set all the host bit to 0. You will get 193.168.10.0. I want to find the last IP address. In that case, I will set all the host bit to 1. So let's set, and you will get 193.168.10.127. If you notice already, the converted bit is not changed in one subnet. So in one particular subnet, you have to remember that the converted bit does not change. Now if you increment 1 in the last address of the subnet 0, you will get the first address in the subnet 1. Before that, let's first allocate the IP address of the subnet 0. Now the first and the last address will not be allocated to any device in the subnet. Because the first address in the subnet represent the whole subnet and the last address in the subnet represent the broadcast address. So any message sent to the last address of the subnet 0, all the devices in that subnet will receive the message. So what will be the IP address of the first device? The first device will get 193.168.10.1, then 10.2, 10.3, 10.4 up to 10.126. So the first usable IP address in the subnet 0 is the 193.168.10.1 and the last usable is 193.168.10.126. If you increment 1 to the last address of the subnet 0, you will get 193.168.10.127. Now let's see the number of hosts in the subnet 1. To find the host in the subnet 1, you will get using the equation 2 raised to 7. Now what will be the first address in the subnet 1? So if we increment 1 to the last address of the subnet 0, you will get the first address in the subnet 1. What is the last address in the subnet 0? It is 193.168.10.127. So if you increment 1, you will get 193.168.10.128 and notice the converted bit is changed. So converted bit has become 1. And to find the last address in the subnet 1, let's set all the host bits to 1 and you will get 193.168.10.255. Now again, in particular subnet, the first and the last address is not usable, because the first address represents the whole subnet and the last address represents the broadcast address in that subnet. So let's allocate the IP address of the devices in the subnet 1. So what will be the IP address of the first device? It will be 193.168.10.129, then 10.130, 131 up to 10.254. If you increment 1 to the last address of the subnet 1, which is 193.168.10.254, if we increment 1, you will get 193.168.10.255. So that is the broadcast address of subnet 1. If we further increment 1 to the last address of subnet 1, which is 193.168.10.255, you will get 193.168.11.0. So the network is changed. Okay. Now let's find the subnet mask. So to find the subnet mask, we know that we'll set all the network bits, including the converted bits, to 1 and all the host bits to 0. And that is the subnet mask. So if we convert 1 bit from host to network, we get 2 subnet. If we convert 2 bits, we'll get how many subnets? That we are going to see in the next lecture. This is it for today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.